Sometimes you got too much data to render on the server, but if you're gonna let the client do it, then, well, the first thing you're gonna do is show a freaking spinner because, well, the data isn't there. So you kind of want to have a head start where your data is coming from the server and then the client picks it up and you scroll into oblivion. In this video, I'm going to show an example of an infinite scroll that starts with a React server component and loads a client component that does the fetch more data part of it. Very well then, let's begin. So first things first, when we have a page, we need to have a route for that. We're just gonna have this overview path lead to the overview component, straightforward stuff, dynamically rendered. We're gonna render a overview component here on the server. We have a helper function, get feed items, to get the stuff from Pocketbase. So what we do here is we get our Pocketbase instance from our middleware. So that, see last video, we done login and middleware, and then Pocketbase is available via the context. If you don't want to watch that video, that's fine. We just get our Pocketbase instance from here. That's really it. Then we have our data store for that specific table where we look at get list with results. That's actually a little wrapper over here. So the Pocketbase binding has like a get list, give me a list of the current entity and then some options. So we're going to use paging over here, obviously. And in this case, I'm actually returning a result over here. So a promise of a result of the list thing. And that's because we're wrapping this entire promise with some catching logic. So we're doing a try catch over here. We then check, is it like a Pocketbase instance, the error class? So we're doing some runtime check, is it what we think it is? And if it is, let's just create an error for this. If it's not, we're just gonna make a synthetic error. This is a long-winded way to say that I'm doing API calls and I'm returning results because of an additional small binding layer that I'm having. So in essence, I have a list result over here. Then if I have an error, I do need to have the error in something serializable. So what I'm doing here is I'm casting the Pocketbase client instance error. So this is again very specific, but in essence, this is a class that does the is JavaScript error thing. And in order to serialize that, we're just going to take the error and use its toJSON helper method. And then we just get like serializable JSON data, which we can send back to the client. That's going to be a little bit more relevant later. In essence, we just have a page. We're fetching the current page. If we do have the page, we're actually sorting here and we're doing field expands. So we can ask like, if I have relationships in my table, then get me some additional data. A location has a user, like who created it and who was also present. These things will be expanded upon. Again, Pocketbase specific, so not that relevant to the video of today, but in essence, I'm massaging the data I get back from my Pocketbase a little bit to what I'm gonna need to render my data in React. Moving on, we create feed items. This is going to be an overview feed. This is our client component. So we specify our types over in the client component and the dependency goes from the server to the client. In essence, we have our component over here. So this is async. We can have an initial fetch call over here, like give me the first page. And based on, we want to know if we're authenticated. We show a little bit more data to users that aren't authenticated. But in essence, we get the first batch of items. Over here, we pass it to our overview feed. And we try and catch any errors if the server were to be offline or something else has happened. So we're doing error handling server side. Let's take a look at how that works. In essence, we have our overview over here. We passed some items to our client then renders it. And if we go over here, we can sort of scroll. And eventually, if I scroll far enough, then we're gonna have like new fetch calls to get additional data. That's gonna happen in the client component. But initially at the start, when we view at the source, we can see that we already have HTML, something visible on our page from the server to start our infinite scroll list. Now the overview feed is a client component. So up on the top, we need the directive. Why is this a client component? Well, we're doing virtualization and we're going to use TanStack Virtual for that. And we also need to, tweak TanStack Virtual a little bit based on the actual page width that we have. And we're going to have a use effect for that. There's interactivity, obviously. We're doing the scroll that has an event. It's a client component. What can I say? Over here, we have the item definition and the overview error. What we have is a feed state to track the current state. So we're going to start with like an active feed state and just have like a bunch of items. But overall, as we saw in our server function over here, this thing calls the feed items, but in essence returns the results. And we might be scrolling, and at a certain point the server is down. Then we just want to gracefully catch that, and that's why our state can just have like, oh, we received an error, where we keep the track of the error, and we're just going to show that in our feed later on. But in essence, because we model it like that, that's one of the strengths of rescript. It allows us to really think about it ahead of time and deal with error situations, where in JavaScript, if you don't deal with them, then you're just gonna have like a blank page at a certain point. Okay, there's a module, there's a feed item module. This is really just show the thing. So this is all just view logic. Then we have an estimate size. This is a TanStack virtual thing. For TanStack virtual, you should look that up. But in essence, we're just not gonna show all the HTML elements constantly. We're just gonna show the ones that are in our viewport. The viewport is the entire page in this case. And we need to have an estimate size. And when it goes over that certain size of items, then it's going to try and fetch more. This is our main component function over here. So we get the initial items from the server. We get the total amount of items. We actually had that in our initial request call. So if we do one list request to Pocket Base, we actually know how many items there are for that certain query. So we just pass that so that we know if we are at the end, then well, we can do something with that, and we can disable to try to load more. Our server action is again use server, but we can just pass that to the client to invoke it. And this is wonderful stuff, because you don't really need to specify like an API route or something. This is like RPC style, just pass it through. And we also show a little bit more data, so usernames, if the user is authenticated or not. We grab a parent ref. We're going to use a use transition. We're going to have a start transition because we need a little bit more control about our state. We're not doing any form submit or something, so we're just going to use start transition to manually invoke that. We have a use effect because we need the width. So initially we'll have like a parent ref somewhere, and we'll have to see if there's a container width or not. And I'm just using an abort controller to basically detach the event listener. So that's also a rather new browser API. You can pass in a signal over here. When we want a cleanup function from our effect, then we are just going to call the abort controller abort, and then that just like cancels this add event listener. Okay, this is the important stuff, to use action states, where we want to have our current state. Based on that, if we didn't receive any error, we're going to try and potentially get the next state when the load more action is invoked. We of course can only invoke the load action inside of transition, so these typically go hand in hand. In essence, we're just going to invoke the load more that we got from the server to potentially receive some new items, which we can then append to the active state. And if we have an error, then we're just going to show the received error. If we already had an error, we're not going to bother and get more information. That's a choice, because if I'm assuming if there's going to be an error, then the whole thing is probably down or anything. So then we have our use virtualizer. So this is TanStack virtualizer. If you've never seen this before, this is wonderful stuff. If you ever need to do something with an infinite scroll, that would be my go-to. We can say how many things we have right now. So I have this feed state, and there's a helper method get items, just to see, give me the items from whatever state we have. We're having an overscan. How many items do we want to overscan? So I want to scan 2 items more, for example, than I'm already seeing in my viewport. We have an estimate size. So that's like an initial function you need on the server to see how things are going to play out, how many items you need to get rendered. The scroll element is the ref we had, and then the onChange will then see, okay, what kind of state are we in? Are we initially mounting the component or not? Because if we are not initially mounting, then we don't want to have this, triggered automatically. So this is just like to prevent loading immediately when you render a page. We also want to check the transition we're currently in. Are we already requesting for new data or not? And of course, are we, do we have all the data? Maybe we have all the items, then we don't need to do this as well. That's when you're onChange in the virtualizer. So when you're scrolling, basically, then we're going to see that, okay, what is the last item? And we're going to do a load more if that still, works in terms of the overscan. So then we have the load more. And then eventually what you need is parent container, which has then like the scroll bar. Then you need like an inside a container, which has like the fixed height, because this is going to be how many pixels do I actually have based on my virtualizer setting. So this is like how tall are each entry and how many do I have, and then it does some internal calculation on that. Then we can get the virtual items that should be displayed. We are going to check our feed state, get the items, and then do like an option map to get actual HTML items. We're going to map that to like a React array. And here we're just passing the actual feed item. So I just wanted to encapsulate that so I don't need to take the virtualization logic into account of that feed item if I ever want to potentially really reuse it. And then based on the feed state, if we do have an error, we want to see something at the end. And that's pretty much how this works. So let's go to the browser one more time. We're in over here, we're scrolling. At a certain point, our on change is going to be hit. Like we can see over here, our on change was hit. So what happens? We check the items, we check if we can load more items. If we do, we just invoke that. And then we're going to update the feed state. And because the feed state is updated, the virtualizer will show the next items from the feed state. So we do have everything still in memory, but the thing that we're only going to render to React is provided by the virtualizer. So my two dev servers are running here. This is the Waku dev server and this is my Pocket base. So if I were to stop the connection with the Pocket base, Waku is going to try and do a call over here in the fetch next. So we're going to try and get more feed items. We can't, obviously, because the server's down. And if we now go and try and scroll a bit, we'll eventually see that, okay, we could not load the data. There was no way to load additional data. I'm just dumping the error here for now. Probably gonna do something more user-friendly, but you get the idea. We can catch the error and just show something based because the type system forces us to think about errors. If you were to do like a full page refresh, then we can also do that, but obviously we cannot on the server do the initial rendering. So how does that look like? Well, it initially is going to get feed items, it failed, and then we just show in the server offline component, which seemed relevant for me to like show on multiple pages, because if Pocket Base is ever down, then that's just going to be a problem going forward. I really like this one. So the server and the client just do the rendering in the exact same way. There's an easy head start to just like render the first thing in a very SEO friendly way, like the data's there, we're showing something immediately in the browser. But then when we scroll, we do the nicely tight integration with our client component, and it works out really well. And it's one of the nice use cases of React Server Components altogether. Thank you for watching this video. I'm really enjoying the rewrite of this beta app. There are a lot of interesting things in here, and I think React Server Components solve certain cases very elegantly. That's all for today. Until we meet again.